And we need to get it wrapped up. So here we are. Okay, so yesterday we were doing word problem number 57, which was Julie's patio, and we had settled at least on the beginnings of an equation. So let's wait. We're no longer. Why would I mark you? Well, that's an old X. That's not an old X. We had an X at one point. All right. So this is the equation that we had come up with. Remember, we drew the garden, we put the patio around it. We knew that the area of the whole shebang, I'm looking at my word problem sheet here, the area of the whole thing was 1,504. So this is our equation, and we're solving it. So, what should we do? FOIL. So,
1,000 plus 50x plus 80x plus 4x squared equals 1,000.
Wait a second. You guys are too much.
You gotta slow down first.
Alright, so I have 4x squared plus 130x minus 504. Keep an eye on that arithmetic. Does that look right? If I get it set equal to 0?
Yep.
And of course I want to get it set equal to 0 because it's quadratic. And I might be able to factor it. I don't know, those are really big numbers. Or I can always use the quadratic formula. Now, are all of those by chance divisible by 4? So I think I'm just going to go with it. Does anybody see how that factors right off the bat? So x equals negative b plus or minus the square root of b squared, whoops, b squared minus 4 times a times c all over 2a. Hold your breath. Is that a square? Alright. So negative 130 plus or minus 158. All that worked out to be that, which is a perfect square. So 138 minus 130 divided by 8. One answer is 3.5. Oh, and the other one won't matter because the other answer will be negative. And I know I erased my picture yesterday. Hopefully you have it written down. But remember, what was x? X was the width of the walkway. So it can't be negative. So how wide is the walkway? 3.5. Big numbers, scary numbers. You got a calculator. Do you know how to practice? Do it. Alright, I'm not going to get bogged down in these word problems like I did last time, but there are a couple here we need to do. We need to do number 58 and 59. Yeah, we need to do 58 and 59. Alright, so everybody good here? Alright, number 58. 58, let's see what's happening. It's 58. The Welcome Home Apartment Rental Company has 1,600 units available, and 800 are rented at $300 a month. Okay, so right now I have 800 of them rented at $300 a month. A market survey indicates that each $5 decrease in rent, so every $5, this goes down, if I subtract $5 from the rent, I'll end up renting 20 more apartments. Do you understand what's happening in the problem? Right now, I'm the landlord, my monthly income is 800 times 300. I have 800 apartments, I'm renting them for $300 each. Does that make sense to you? But I want to make more money because I'm a business person, and I somehow figured out through a survey or whatever that if I lower my rent $5, I'll have 20 more customers. Well, what if I lowered my rent $10?
40.
I have 40 more. So the question is, how much should I lower my rent to get the maximum income? Because at some point, do you agree my rent will get so low that I won't make as much money? I gotta find that tipping point. Does that make sense to you? Okay, so let's understand that to find my income, I multiply the number of rentals times the rent. Would you agree with that? That's how I get my income? Well, how many units am I renting? What are my number of rentals? Well, it's 800, but what is that doing? That number is going to go up in increments of 20.
Plus 20.
So plus 20x, that's it. X is how many increments I'm gonna have. How many times am I changing my price? I don't know, that's what I'm gonna figure out. Now, what's my rent? Well, it started out at 300, but what's happening to the rent?
Minus 5.
It's going down in increments of 5. So here's an equation. Let's FOIL it out. Use your calculator, because Lord only knows what I'm doing here. Did I get the right number of zeros on things? Is that right? Is that okay? Now, what is that? That's a parabola, isn't it? And it's a parabola opening down. Well, wait a second. What am I trying to figure out? How do I make the most maximum money? If I have a parabola opening down, where is the maximum going to come from? The vertex. And how do I find my vertex? X equals
2b.
negative b over 2a. So negative 2,000 over negative 200, negative b over 2a, and what is that, 10? Now be careful, what does that 10 represent?
The maximum.
No, that's not a maximum. That
What's the
10
Oh, it's not.
is
yeah.
X. And what was X? X was the number of times I changed my price, right? Every X gained 20 people. Every X lost $5. So what is the question? I got the function, not graphing it. What rent will yield the maximum monthly income? What rent? Well, my original rent was $300, but I'm gonna lower it 10 times. And every time I lower it, it's going down by $5. So $250 is the rent that you should charge to make the most money. What's the matter, Patton?
Wait, so can you explain, like, why, like, you know when to, like, answer, like, what would the question ask if it would be used to, like, the least amount? I don't know.
Okay, so let's just stop a minute. Would I ever, in a business situation, and I'm talking about income, would I ever want to minimize that? Never. Right? I might want to minimize my expenses or something like that, but I'm never going to minimize my income. Right? So this is going to be a maximum. Luckily, because what did this end up being? A parabola opening down. That's going to be a maximum problem.
What does the Y represent?
The Y represents
The
the
income?
total income. That's your income. So if you just figured out we're gonna charge $250, we're gonna rent out 1,000 apartments because 10 times 20 is 200 plus the original 800. So 1,000 apartments at $250 each is gonna be my maximum income. Let's try 59 is exactly the same thing. So let's see if we can power through number 59. What's happening here? Well, we're selling soda. The Sweet Beverage Company. And right now, they're selling 26,000 cans at 50 cents each. They know that if they increase the price by 5 cents, what's going to happen? They're going to lose 1,000 cans. So question C is the question. How much should they charge to get the maximum revenue? How much should they charge? Should they drop it once and charge, or excuse me, raise it? Should they raise it once and charge 55? Twice and charge 60? How much should they raise it to bring in the most money? Well, how do they calculate their income? Right now, how do they calculate their income? The number of cans sold times the price, right? Now, how many cans are they selling?
26,000.
Right now, it's 26,000.
Plus 50.
But
Minus
what's
1,000.
happening to the 26,000?
Minus 1,000.
It's going down in increments of 1,000. Right? We're losing money. I mean, we're losing our customers. Now, what's the price? Well, right now, it's 0.50, 50 cents, $0.50. But what's happening to the price? It is going up by a nickel or 0.05x. All right. Let's FOIL. I have no idea. write down what I wrote. I don't even know if it's right. I'm checking it on my calculator. Okay, so this should be 50. So for your quadratic, did you get negative 50x squared plus 800x plus 13,000?
Yeah.
Now again, guys, look at it. What is that?
That's a parabola.
That's a parabola opening down. The maximum is going to come from the vertex. And we can find the vertex by doing negative b over 2a. So negative b over 2a. Do you get 8?
Yeah.
Now that 8 is the number of increments, x. Your question was, how much should they charge per can? So right now they're charging 50 cents. But they're gonna raise that price 8 times. And each raise is 5 cents. So they're gonna raise it by 40 cents. So what price should they be charging?
90 cents.
90 cents a can. 90 cents a can. And if they charge 90 cents a can, what will be their revenue? Well, they're charging 90 cents a can. How many cans are they gonna be selling? Well, remember, they're raising their price 8 times. So they're gonna lose 8,000 cans?
18,000.
So they're gonna sell 18,000 of them at 90 cents each? What is that?
16,000.
16,200? So what will be their revenue? 16,200. Now, to kind of put that in perspective, guys, in the beginning, they were selling 26,000 cans at 50 cents each. So what was their income then? $13,000. But by making these adjustments, now they're making $16,200. And that's the maximum. Okay? All right, I'm gonna skip the last 2. And we're gonna move on into, we still need our paper though. Still need your book paper because we got a bunch of book problems here. But we're moving on to variations. So section 2.2, 2.1 will be due on Thursday. 2.1 will be due on Thursday. Now 2.2. I want you to think of 2 situations real quick. All right? Think of these 2 situations. I love bananas. I go to the store and I buy bananas every week. The more bananas I buy, the more money I pay. Would you agree with me?
Yeah.
So more bananas means more money. Okay. Now, when I drive to school, if I drive 30 miles an hour, it takes me a certain amount of time to get here. If I drive 40 miles an hour, it takes me less time to get here.
Yeah.
So more speed, less time. So more bananas, more money. More speed, less time. Those are the two main kinds of variation. In direct variation, both variables move in the same direction. So more bananas, more money. Less bananas, less money. That's called direct variation. And the formula for direct variation, I call it the general equation for direct variation is y equals, I almost said mx, y equals kx. Okay, that's direct. So what is direct variation again? Both things in the problem are moving the same way. They're both getting bigger, they're both getting smaller. Okay? Think of height and weight. Generally speaking, the more height you have, the more weight you have. Not always, but generally speaking, that's a direct variation. Okay? Now the other one is called inverse variation. That's where one thing goes up and the other one comes down. Inverse variation is y equals k over x. Okay, so those are just the general formulas that you're going to need to stick away in your head. Okay. A power function is a function where x is raised to a power. Those are called power functions. And it can be any power. Okay? Tell me which of your BFFs are power functions. Be careful.
Exponential.
Exponential is not a power function because in a power function, x is the base. So this is not one.
It's the last one we learned. It's like 1 over.
So I heard cubing,
Squaring.
squaring.
It's like the 1 over 1 minus x.
1 over x is a power function because that's the same as x to the
What about the last one we
negative
learned?
first.
That's like 1 over 1 minus e of x.
No, because again, if you're going to be a power function, x has to be the base. So think of it as x to a power. Okay, it's got to be x to a power. So there's at least one more I can think of. Yes, y equals the square root of x because that's x to the 1/2. How about y equals x? Linear, x to the first. Trying to think, not absolute value, not sine and cosine, not greatest integer, not logistic, not logarithm, and not exponential. This is it right here. That's it. Those are all power functions. All right, so let's get out our sheet, and let's on page 197 sheet. This is from your textbook, number 37. So 37 to 42, we are matching up those equations with those curves. So let's look at just the quadrant 1 ones. We got a picture that looks like this. By the way, when have you ever seen something that looked like that?
Y equals
1 over x. So in other words, x to a negative power. So let's look, 37 to 42, are any of them
38.
x to a negative power? 38 would
41.
be. Now, 41 is a little different because since 41 is negative, it actually would be down here. So this one would be, what do you say, 38? And this one would be 41 because it's got a negative coefficient. All right, good, that's good. How about this? What's that?
Not right.
That's linear direct variation. That's equation C. Do I have one of those on here? No, I don't see one. All right, that's okay. What about this one? D, I think it is. Have you ever seen anything
That's the
that
square
looks like D
root.
before?
Square root.
That's your square root. So that's a fractional exponent less than 1. So do I have one of those?
39.
42. What else? You said 39.
44.
Oh, you're down here, 44. Now, 44 is okay, but it would be negative. It would be down here
Oh,
because of the negative coefficient.
yeah.
Okay? And then this one's probably the trickiest, although you can figure it out. What about this shape? When do you see that shape?
That's the exponent.
You see it twice.
Cube.
You see it with a cube and you also see it with an exponent. That happens when the power is bigger than 1. See, this is a power less than 1. This is a power of 1. And this is a power greater than 1. So which ones have a power greater than 1?
37.
It's negative.
That's the only negative.
Well, 37 is negative, so it would be that going the other way. 40. Oh, let me find 40. 40. That one is also negative, so that would be going the other way. Well, you go down there. How about down below? 43. Any of those? That one? Oh yeah, 46. 46 would be that one. Okay, so the purpose of that exercise is for you to understand that when you're a power function, the curve is always going to behave the same way. If the power is bigger than 1, you're going to have that like parabola or cubey look, okay? If it's equal to 1, it's of course a line. And if it's less than 1, it has the square root look. If the exponent is negative, it has the reciprocal look. 1 over. No matter what the exponents are. Okay, we got bigger than 1, equal to 1, less than 1, and negative. Okay, y'all good? All right, now 197, number 17. Where's number 17? Oh shoot, the numbers got cut off. I think it's the first one there. Write a statement as a power function equation. Use k for the constant if 1 is not given. All right, so let's not get bogged down by those directions. Let's get this, a couple of these done, then we'll go to 1. The area of an equilateral triangle varies directly as the square of the length of the side. So the area varies directly as s squared. All right? Varies directly. Area varies directly as side squared. That's all you have to do. That's your equation. This is your direct variation equation always. Your variables or quantities are y and x. K is a constant, a number, like 6. Area varies directly, that tells me I'm using that format, as s squared. So my quantities are a and s squared. Okay? We'll pick up there. Come back to 45. We will pick up where we left off. Yeah? Have a good lunch.